So we are continuing our example we had last time, comparing the proportions of men and women living at home. So we had group 1 was men, group 2 was women, and we were talking about young adults 18 to 25, or 19 to 25, and we wanted to see if we had evidence that different proportions of men and women lived at home. So we wrote out the information we had, and we conducted a hypothesis test last time. We stated our initial claim, 2 groups are the same, our research question to see if they're different, calculated our test statistic, how far our data is from the assumption of no difference. We saw it was really far off, and we converted that to a probability of basically never, 6.7 times 10 in the negative 10th percent of the time. We put those two together in our interpretation, saying if they're the same under the null, we basically got no chance, a really small percent of the time we're going to see this kind of data. And that resulted in us having very strong evidence for our research claim that the proportions are indeed different. So again, very strong evidence for HA that the proportions are different. And I left you with this question. It says, based on the hypothesis test, would a confidence interval for P1 minus P2 contain 0? So hopefully you thought about this and tried to answer it on your own and then actually worked out the interval to confirm your answer. So again, based on the hypothesis test, we don't want you to work anything out at first. Is our interval going to contain 0? And hopefully most of you guys said, no, it should not. So why? I'll say a confidence interval for P1 minus P2 will not contain 0 because, and the hint was in check out your hypothesis test. So on our hypothesis test, we concluded we had really strong evidence the proportions are different, or we have really strong evidence for HA. So look how we wrote HA. We have really strong evidence, their difference is not 0. So 0 shouldn't be in there because we have strong evidence that it's not 0. So let's finish writing that down. Confidence interval for P1 and P2 will, I said one thing and wrote something else, will not contain 0 because we have very strong evidence, according to our hypothesis test, that P1 minus P2 is not 0. Or in other words, we have really strong evidence for HA. So since we have strong evidence it's not 0, the confidence interval should not contain 0. So let's actually check it out and work out the confidence interval. So remember, our confidence interval, we need the same 3 pieces every single time, no matter the setting. Our point estimate, so if we're estimating P1 minus P2, we said just use the difference in the data, our P1 hat minus P2 hat. We have that from the previous page, our 0.4376 is the proportion of young men still living at home. 0.3511 was the proportion of young women living at home, and that gave us our between 8 and 9-ish% still living, a difference in the 2 groups. So based on the data, there's our difference. We need our multiplier to give us our level of confidence. So earlier it asked for 95% confidence. Let's draw it out as a reminder. Pretend that's a normal curve, kind of skewed here. But we've got 95 in the middle. And then on either side, we've got our 2.5% left because it's symmetric. And specifically, it's symmetric around 0. So all I need to do is find one of these guys, and I get this, it's plus or minus of the same thing. So Z star, we're going to use inverse norm because that gives us a Z-score when we put in a probability. So if I plug in 0.025, it'll give me this z-score that has 2.5% below it. That's going to be the negative version of it. Yep. And then all I need to do is take the absolute value, make sure I report the positive version, and that would give me 1.96. Alternatively, you could put in 0.975, the area below this, the 95 plus 2.5, to get the positive version. Either way, it gets you the same place. All right, then the last of the three pieces is our standard error. Remember, this is very, 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 very important. Standard error is different for a hypothesis test and a confidence interval. Confidence interval, we have no HO, we have no initial assumption. So we're not combining the two groups. We keep them as two separate groups. So the variability contributed by the men is their P1 hat, so 0.4376 times 1 minus that number, over their sample size of 2,253, plus the same term for the ladies, so 0.3511, and then 1 minus that number, over the sample size for the ladies, which was our 2629. And when you work that out, you get 0.014. Now you might think, hey, this is the same exact number we had for the hypothesis test. If you round it to 4 decimals or a few more, yes, it looks the same. But if you take it out anymore, they are in fact different numbers. We just have such big sample sizes here that they are going to look very similar in those two different standard errors. Then, as a reminder, putting these together, our margin of error is our multiplier times standard error. So we've got those values. Our multiplier was the 1.96. Our standard error is the 0.014. And multiplying those together, we get our 0.02744 for our margin of error. Okay, so almost there. Let's just put all the pieces together now. We have our three main parts. So the actual confidence interval is our point estimate plus or minus our margin of error. Putting in our numbers here based on the data, the difference in the two proportions is 0.0865 plus or minus our margin of error we just found, the 0.0274. And again, we like you to go one more step, even though in journals and whatnot, they often leave it like this. We want you to go one more step to give us the full interval. Make sure you're doing the subtraction first. So 0.0865 minus the margin of error to get your lower end point, and then 0.0865 plus the margin of error to get your upper end point. Now remember what we said earlier. This guy is entirely positive. What does it mean when our interval is entirely positive? Which group is larger? If you're thinking group 1, you're absolutely right. So I'll say all positive. So group 1 is larger. And then also notice that 0 is not in the interval. Up here we said we had really strong evidence, very strong evidence that the difference is something other than 0. So 0 should not be in our interval. And sure enough, 0 is not in our interval. This range just covers between some positive values on the number line, negative and 0 not in here. So this does confirm what we found earlier. All right, let's just finish up with our interpretation here. So interpretation, we've got our same three parts we're looking for. How confident you are. So in this case, we are 95% confident. Then state what you're interpreting here, what you're estimating. So here we're estimating the difference in proportions. Be very, very careful. Not one proportion, but the difference in two proportions. So we're 95% confident the difference in proportions of men and women living at home Okay, again, you might see some people say the true difference, the population difference, that all that is really good. We're not talking about the data, we're talking about the whole population. So we're 95% confident the difference of proportions of men and women living at home is between, and give our range here. Our 6-ish% and 11%. So between 0.0591 and 0.1139. All right, so you've seen an example of hypothesis testing confidence interval for two proportions. Hopefully you're getting comfortable that the framework, the pieces for this are the same between one proportion and two proportions. There's going to be one more video to wrap up some of these ideas. So before you go to that one, try out the example on the next page. It has a little bit of a different twist to it. See if you can figure that out. Try that example, then watch the next video so we can wrap up this idea of inference for two proportions.